In the fall of 2018, members from the Program Executive Office Command Control Communications Tactical visited the National Training Center as part of their command post signature reduction effort. From that visit, in February of 2020, a small group of professionals comprised of members from NTC Cyberspace Electromagnetic Activities, PEOC-3T, and operators from CTL System were assembled to conduct an EMS assessment for study with the proper equipment, personnel, and environment at the NTC. The intent was to capture the critical vulnerabilities of a BCT's use of the EMS and provide recommendations to mitigate and minimize risk. Though the observations, assessments and comments throughout this video are focused primarily on one Brigade Combat Team command post, similar actions have been observed dating back to FY17, throughout all the combined training centers. The units subject to the study were not informed of this assessment to prevent any changes in behavior. Observer coach trainers' emissions were mitigated as much as possible to prevent interference with the study. CTL Systemware provided the Spectrum Guard Pro that would be used as the hardware required to collect and record all the data. At the time, the Spectrum Guard was not integrated with the Army's program of record electronic warfare planning and management tool, which was used to provide the graphics. A segment later in this video will demonstrate integration efforts that have taken place that allow soldiers to provide real-time RF visualization using the Spectrum Guard and EWPMT. Understanding the severity of the emissions threat, and developing internal procedures to mitigate and impart greater situational awareness of the use of the EMS to all soldiers from commanders down to the lowest level may prevent catastrophic losses to the force, ensuring, enabling, and supporting survivability in tomorrow's conflicts. The results of the study were staggering to say the least. I wrote several white papers and even an electronic warfare handbook to try and educate soldiers on why we need to look harder at emissions control and one step further why we need equipment that will allow us to see ourselves in the electromagnetic spectrum in order to conduct better radio frequency hygiene. The purpose of the following video is to show electronic warfare soldiers that there has been work done within our program of records such as EWPMT using RF measurement equipment such as the Spectrum Guard Pro that will allow us to visualize the EMS and make informed decisions on how we can use our mission command equipment, develop the PACE plan, and enforce emissions control. To demonstrate the integration, I'm going to start by running a baseline. Although the Spectrum Guard has the capability of covering 0 to 26.5 GHz for the purposes of this demo, I'm going to set my baseline measurement to cover 300 to 400 MHz. I'll let the Spectrum Guard scan the 100 MHz baseline 1000 times before I run a comparison. I'm running my baseline in the range of a vehicle key fob, but this could be done for the entire 26.5 GHz frequency range that the Spectrum Guard covers, although it would take a few more minutes to conduct the baseline sweep. What this allows is for a unit to sample the RF environment prior to entering an area of TOC operations and then compare the environment once the unit has occupied the operational area to see how their RF emissions would look to an adversary. Once the scans are complete, I conduct my comparison, and anything that was not present during my baseline, such as new signals that I am generating, will populate within EWPMT as an emitter report. For the purposes of this demo, I used my vehicle's key fob, which generated a 313 MHz signal. Now, using the plugin within EWPMT, I can right-click on the emitter report using the Spectrum Guard sensor view to begin taking a look at that signal. There are quite a few different ways to view that signal within the multitude of spectrum views included within the Spectrum Guard, but for this demo I'll show you my favorite two. These are the waterfall display and the 3D visualization tool. Once I take a look at that signal and decide if it is a signal of interest, I can then go back to EWPMT and view the map. Then find the signal of interest. By simply right-clicking on the graphic representing the emitter I am looking at, I can create a coverage map. The pop-up window allows me to manipulate some of the characteristics of the signal, and as you can see in the bottom left there are advanced settings that allow me to adjust antenna characteristics. I'm on a multitude of other equipment parameters. Again, for this demo I'm keeping it simple. I'm going to adjust the power settings and then create a coverage map. After a few moments EWPMT will generate an RF propagation model using the signal characteristics and digital terrain elevation models, producing an easy-to-interpret keep map. Additionally, I have a power legend associated to the power levels of the signal which I can adjust in the user preferences. This concludes the demo of a simple yet effective method HEWAs can use to officialize their own emissions within the RF spectrum. When done correctly, this can help inform commanders on better methods of employing their PACE plan and emission control procedures to enhance force protection when competing in multi-domain large-scale combat operations.